Hello and welcome to another exciting chemistry session. This is your host, Mr. Monsa, chemistry tutor. So we are still in the series of acids, bases, and salts. In lesson 1, we tried to describe what an acid is. We looked at the organic acids, inorganic acids, what is the strong and what is the weak acid, what are concentrated, what are dilute acids. We looked at the physical properties of an acid. In lesson 2, we spent much of the time talking about the chemical properties of an acid. So in this video, we want to understand what a base is. So we'll try to describe what a base is and what is its chemical composition. What is its chemical composition? What is referred to as a soluble base? What is an insoluble base? What are the physical properties of a base? And what are the chemical reactions that a base undergo? So quickly, we'll start by describing what a base is. So a base is a substance which, when reacted with an acid, it produces a salt and water only. So this is referred to as a neutralization reaction. Now, if we're going to understand a base, we have to understand its chemical composition. So by chemical composition, we mean the forms in which this base exists. So a base exists in three forms. We have a base which is a metal oxide. We have a base which is a metal hydroxide. And we have a base which is a metal carbonate. These are the three forms in which bases exist. What do they mean when they say a metal oxide? So a metal oxide is when a metal is combined with oxygen. You get a metal, you combine it with oxygen. A compound that you're going to form will be called a metal oxide. For example, you get sodium and you combine it with oxygen. What you will produce will be called sodium oxide. That is an example of a metal oxide. Here, if I get calcium, I combine it with oxygen, I will produce what is called calcium oxide. That is an example of a metal oxide base. If I get zinc, I combine it with oxygen, I will get zinc oxide. Let's quickly look at a metal hydroxide. Metal hydroxide is a combination of a metal and hydroxide. If you remember the radicals, hydroxide is OH, capital O, capital H. This is a radical called hydroxide. Metal hydroxide, I get aluminium and I combine it with hydroxide. I will produce what is known as aluminium hydroxide. If I get magnesium, I combine it with hydroxide, I will get what is known as magnesium hydroxide. That is equally a base which is existing in a different state. Then, lastly, we'll look at what is known as a metal carbonate. A metal carbonate is when a metal combines with a radical called carbonate. Carbonate is C, capital C, capital O, subscript 3. Potassium combines with carbonate, I will have what is known as potassium carbonate. Iron carbonate, barium carbonate. These are the three forms in which bases exist. Now, these three forms exist in different states of matter. A metal oxide exists in solid state. So whenever they write a metal oxide, they will use a state symbol of S. Metal hydroxide exists in aqueous state. Whenever they write this in chemical equation or in chemical equations, they will use state symbol AQ. Metal carbonate exists in solid state, meaning whenever they write a metal carbonate in a chemical equation, they will use the state symbol of S. So those are the three forms in which a base exists. Now, this base can be soluble and sometimes it can be insoluble. What do they mean when they say a base is soluble? A base is soluble when it is capable of dissolving. When it is capable of dissolving. And this dissolving can be fully or can be partially. What is an insoluble base? An insoluble base is a base that do not dissolve. A base that cannot dissolve. Therefore, when we are looking at solubility of bases, we focus much on the soluble base. A base that is capable of dissolving is known as an alkali. Is known as an alkali. An alkali is known as an alkali. So an alkali is a soluble base, a base that is capable of dissolving. Examples of soluble bases, we have sodium hydroxide, potassium hydroxide, and calcium hydroxide. These are bases that can dissolve. Let's understand what an alkali is. But remember, an alkali is just a soluble base. So, when an alkali is dissolved in water, it produces hydroxide ions, which is capital O, OH, negative. So when an alkali dissolves microscopically, what we're supposed to see is OH negative in the container as the only negatively charged particle. Meaning the only negatively charged particle that we should be able to see when we dissolve a base is OH negative. If this is my container, the only negative that I should be able to see in the container if I'm dealing with a base is hydroxide, OH negative. Of course, there will be other things, but the only negatively charged particle I should be able to see in a container is hydroxide. That is what they are trying to say here. Let's quickly look at the strength of an alkali. Remember, an alkali is just a soluble base. In terms of strength of a base, the strength of a base is the ability to produce hydroxide ions, the ability to produce or release or liberate hydroxide ions. Let's quickly look at a strong base. So this is similar to the acids. When we're talking about a strong base is a base that dissociates completely or fully and produces hydroxide ions. So it's similar to the acids. It's complete dissociation. Remember, complete dissociation is determined by a single positive arrow. And this is what this table is trying to depict. So when potassium hydroxide, which is a strong soluble base, undergoes dissociation, we'll get the K positive, and it should always give us hydroxide. Remember, you have to balance the atoms and you balance the charges. Calcium hydroxide will get calcium ions and hydroxide ions. Similar to the dissociation of acids. If you haven't learned about dissociation of an acid, under this same series, go and look for lesson number 1, and you will be able to understand the meaning of dissociation of an acid. A weak alkali is an alkali that dissociates partially. So the key words or the key word there is partially, partial dissociation. Similar with the dissociation of a weak acid. As usual, weak or partial dissociation is denoted by reversible reaction arrows. So what we have here are just examples of partial dissociation of magnesium hydroxide, iron 3 hydroxide, zinc 2 hydroxide. All right, we can move and look at what do they mean when they say a concentrated base. What determines a concentrated base is the concentration of hydroxide ions. So a base is concentrated when it has or when there is a higher concentration of hydroxide ions. A base is dilute when there is a lower concentration of hydroxide ions. What are the physical properties of a base? How do we physically identify a base? If we can test baking soda, go to the kitchen and have a taste of baking soda, just a bit, have a taste of it. You will have a bitter taste, or you will get a bitter taste on the tongue. If we get a pH meter, which we'll soon talk about in the videos to come, when you get a pH meter, you dip it in the solution, which is a base. On the digital screen, it will record a pH that is greater than 7. In terms of identity test of an acid, if you walk in the lab and you find two colorless solutions and you're not certain of their nature, and yet you are required to identify which one is an acid or which one is a base. So if I'm going to identify a base, I'm going to use a red litmus paper. I'm going to use a red litmus paper and dip it in the solution. I will observe that red litmus paper changing to blue. That is the confirmation that what is contained in that beaker is a base. Bases undergo two chemical reactions. The first reaction is neutralization reaction. They react with an acid to produce salt and water only. This is known as a neutralization reaction. Neutralization reaction. Then bases react with ammonium salts to produce salt, water, and ammonia gas. This is a laboratory preparation of ammonia gas. If you want to produce ammonia gas, you can use this experiment. You take a base, which is an ammonium salt, and you react it with, you get the base, which can be sodium hydroxide or magnesium hydroxide or calcium hydroxide, and you react it with an ammonium salt. It will produce a salt, water, and ammonia gas. This is used in the preparation of ammonia gas in the laboratory. The table here shows us examples of ammonium salts. So we have ammonium salts such as ammonium chloride, ammonium sulfate, ammonium nitrate, ammonium carbonate. So when these salts react with a base, And this base can be sodium hydroxide, can be potassium hydroxide. We will produce a salt, which is sodium chloride. We will produce ammonia gas, and we will produce water. So a base undergoes two chemical reactions. The first reaction is neutralization reaction. The second reaction is a reaction with ammonium salts that will produce a salt, water, and ammonia gas. We have come to the end of this session. If there are questions pertaining to what we have discussed, feel free to post those questions in the comment section. And if there are topics that you want us to tackle, feel free to post those topics in the comment section. It has been your host, Mr. Monsa, your chemistry tutor. Until next time.